Directory and directory structure. Directory, you can simply assume, if you are using some operating system, then directory can just be assumed to be a collection of files. But when we are actually going to the disk and try to find out what is the directory structure, so directory, the collection of nodes containing information about files. So if this is a directory, this directory is simply the collection of nodes, nothing else, containing the information about these files. See, these are files. So the collection of these nodes are nothing but the directories, and they both either you talk about the directory structure or you talk about files, you find it on the disk. If you want more backup, then you can go to some tape drives, etc. So this is a kind of typical file system organization. We can have, say, some different disk, and you can put a file inside a directory. So you might have seen the Windows. So you have partition like this, and D colon this, E colon this. So you have multiple disk which can contain the directory apart from the file, but this is a partition of this. So I'm talking about the partition, and multiple disks can be utilized. But in one disk also you can have a directory. Inside this you have a file. You can make a partition. You can make another partition in this, and you can have another directory. When we talk about storage structure, when you want to organize a data, means you cannot just have haphazard data. You want some organization of data, that can be done in various ways. First is the disk. These are split into one or more partition that I just told you, like C colon slash and D colon E, like this. And whenever you put a pen drive, you might have seen some other partition would come. So each partition contain information about files within it. What are the information? Because every partition will, if you put some files, it will contain information about the file. So it can be name, location, size, and type in a device directory. So the directory, the operation that you can perform on a directory, say you have a directory, and inside this, so this is a directory. Inside this you have multiple files. Now you can search for a file. In Windows, when you open File Explorer, you can find a search tab here, or you can say search space here. So you can search a file, you can create a file, you can delete a file, you can list a directory, you can rename a file, you can also traverse the file system. So there can be multiple scenario in a directory in the terms of how it is organized. The single level directory. So all files, there is just one directory. You can start with the main directory, and all these files are contained in the same directory. But the limitation is you cannot have the same name, because they will conflict. So a single directory, that is for all users, only one directory for all these users, and they have these files. All these files are contained inside this directory. So there is a naming problem, of course, because you cannot have multiple files with same name, and grouping also cannot be done. That is why we go ahead for a two-level directory. What this two-level directory means, here you have a user. So this user, we have separate directory for a user. We call it as UFD, user file directory. We call it as a UFD, and each entry in the MFD points to a UFD. This is a user, and you have a user file directory here, and this user file directory is pointing to this MFD. This is master file directory, this is MFD, and each user file directory 1, 2, 3, 4, all these, they are pointing to the corresponding UFD. And one thing is that no file name collision among different users. See, I can have a here, I can have a file name A here, I can have a file name A here, and also I can have a file name A here also. So there will be no file name collision. But the disadvantage of this scheme is, because these are users and they are isolated, they are separate from one another, and for the same task they may not be able to cooperate. For example, the compilers, loaders, library, they can be put in some system file, say some special directory, say user 0. These are user 1 to 4, you can have some user 0. And this user 0, that may contain compiler, loader, library. These are system files. So that when the operation is for these has to be performed, it can be searched. So this is searched, and the if operating system doesn't find these in the local directory, say UFD, then it can go to this one. And what will be the search path? Because every time you have to give some search path. So the directory sequence is searched when a file is named. This is how the search path here is. We start with the path name, and we can have same file name for different users. This what we have seen. The searching is good here, but the grouping capability, I want to group these three or these five. Say, I may not be able to group them here. So we have tree structure directory. Now user can create their own subdirectories and organize files. So user 1, he'll be able to make a directory, some subdirectory, some subdirectory of some directory. So this is possible in tree directory or tree structure directory. So there are two things: absolute path names and relative path names. Absolute path names always begin with the root, right from the scratch, from the start. And when you are on to some current directory, say you are here at this point. So relative path name, it defines a path from the current directory. From if you are here, it will start from here, not from here. And in order to delete a say empty directory, you just delete it. But if you want to delete a non-empty directory, a directory which is non-empty, first you delete all the files in the directory, and then you delete all the directory files and subdirectories. This is what you do. The searching in this tree structure directory is quite good, efficient, and the grouping capability is also there. So this is how it goes. This is if you start with some current directory, say I want to change directory. I start with spell here. Then I have mail, and then I have spell inside mail, and then I have program. So I can go to the program part like this. Okay, this is how the organization goes. When we talk about some absolute or relative path, if say you want to create a new file in current directory, or you can delete a file like RM is remove, mkdir is make directory. For instance, if you are in the current directory, say this mail, then you just have to say mkdir because you are already in mail. You are here, you are in this directory. Now you can just say, when you come here at this point, you can make a directory count inside this mail. Okay. When you want to delete this mail, if you want to delete this node, I must say, deleting the entire subtree, all the subtree means you can have tree for copy also, for PRT also. So you are just deleting the entire subtree rooted by this mail. Acyclic graph directories. Now see this one. I'll show you the diagram first. This is a kind of formation which we have. We have root with some DICT dictionary or spelling, and then we have all these linked, and this count and this count have this common, right? Now let us see what we want to express here. First, these directories can have shared subdirectories and files. As you just saw, directories can have shared subdirectories and files, and because of this we can have very simple algorithms to traverse the graph. Okay, so only one file exists. So when we have shared, this one is sharing, this one is also using this one is also using this. So only one instance is there. So if you change it, all others may be able to visualize it and use it. And how to implement this shared files or subdirectory? We just have to create a new directory entry called a link. See, this is how to implement the shared files or subdirectories. We just have to create a directory entry which is called as link, and which is actually a pointer. So this is nothing but a pointer to another file or subdirectory. This is a pointer. And if you have duplicate, means duplication of all information about shared files in both the sharing directories, you have to duplicate it. But we have some problems here also. A file may now have multiple absolute name paths. Okay, the names or absolute path name can be or can have multiple, because we are dealing with the sharing also. And deletion may leave some dangling pointers to a non-existent file. Means this is pointing, this is pointing, this is pointing. If I delete it, say, all these may be dangling. If I have deleted for this may be, this pointer may not be there, but this pointer may be pointing to something which is not there. How to solve this deletion problem? We can have back pointers. We need to delete all the pointers. We don't want any dangling pointers. And we can have variable size records. This can also be there. So what we do, there is a back pointers, and this is in the form of daisy chaining. Means this is pointing to this is pointing to this, right? And these approaches to deletion, because deletion is always an issue, with symbolic links, as we just said, what is the link? We remove only the link, not the file. Let the file be there. If the file itself is deleted, the links are left dangling, because they will be dangling, and this can be removed or left until an attempt is to use them. And the other thing can be, we can preserve the file. We can preserve the file until all reference they can be deleted. See, all these are deleted, then we will not have any dangling one. So this mechanism is needed to determine that the last reference to the file has been deleted. The problem can be, we can have a potentially large size of the file reference list. This can be an issue here. So we have, as I just suggested, we have link. Link is nothing but, it is a pointer. That is another name to an existing file. This is just pointing to the same file. So how to resolve the link? Just follow the pointer to locate the file. Just follow the pointer. This point, you go here. This point, you go here. So just follow the pointer. And as I just suggested, how to delete the link, it should goes like the acyclic one. We have general graph directory also. This can have cycles. So the links are added to existing directory. Please understand, this can have cycles. And acyclic means that you don't have any cycle. But this one general graph directory, we can have cycles. So links are added to existing directory if there are cycles. If at all there are cycles, we just want to avoid searching component twice. If it is showing some cycle, or some cycle is like this, you're coming here, so it is making a cycle. So the solution is just to limit the number of directories accessed in a search. And there is a similar problem we encounter when we want to find out or determine when a file can be deleted. So when we have a cycle, this kind of structure, the reference count may be non-zero, even when it is no longer possible to refer to a directory or a file. So this is actually anomaly, and this anomaly results from the possibility of self-referencing in the directory structure. And that garbage collection, when you are trying to delete, this garbage collection is needed to determine when the last reference has been deleted, only because of possible cycles. So this is, as you see here, when we are trying for a general graph directory, we can have cycles, but if there are cycles, these are the solution to it. So how can we guarantee no cycles? We just allow only links to file, not subdirectories. Only links to file, not subdirectories. Okay, and there can be garbage collection, and every time a new link is added, we just use a cycle detection algorithm to determine whether it is okay or not. This is how we guarantee. File system mounting. A file system must be mounted before it can be available to the processes on the system. A file system just can't be used before it can be mounted. So the mounting procedure is something like this. The operating system is given the name of the device and location within the file structure at which to attach the file system. Where to attach? You have to tell which device, what location to the operating system. Now, operating system would verify that the device contains a valid file system or not. It will verify. So if the operating system notes in its directory structure that the file system is mounted at the specified mount point, I'll show you how. See, this is the mount point. We want to mount it here. This is the part we want to mount. A is existing and this is unmounted right now. When you want to mount, you need to link this to the user here. Now you see this Sue, Jane and all these are mounted here. There can be various type of accesses. So systems that don't permit access to other users or other user file, they don't need protection. They don't require protection. And so protection can be provided by just disallow the access, just prohibit the access. But this can be very extreme, So we need some control type of access. This may not be possible because this will leave everything unaccessible. So we need some controlled access. So the limit of we can limit the type of access or file access that can be made. How can we do it? We can control the operations like the read, write, like the delete, and like the list. So we can just allow some files to be read or directories to be read, only return, executable, append, delete list. All these type of accesses are possible, and this is called the controlled access. So what is the access control? This is actually for protection. So the most common approach to the protection problem is just to make access dependent on the identify of the user. What is the identification of the user? That is, files can be associated with some ACL, that is, you have a proper access control list which specify the username and what type of access you allow for that user. But there can again be some situations like how to construct a list. It can be quite tedious sometimes, and the directory entry now needs to be of variable size, and again we need to have some complicated space management. So these problems now can be resolved by combining the access control list with some owner, group, universe, access control scheme. This will resolve the previous problem. So to condense or to just squeeze the length of access control list, that is ACL, many systems recognize three classification of users in connection with each. Many operating systems. This is owner, group, or universities. So or universe. I'm so sorry. Owner, group, and universe. So owner means the user who created the file is actually the owner who created. Now the group is the set of users. Now we have users in this set who are sharing the file and they need similar access in a group or above group. Universe means all other users in the system, they constitute the universe other than this, right? So we can have a sample like this. This is owner access, say it is 7, say group access it is 6, and public access say it is 1. So these owner access can be provided, say read, write, execute. All these are possible. For group access you can give read and write but don't execute. For public access only execute, say, and just don't do read and write. But we can see it other way around also. How? This owner access can be all of these, but group access can be 110. That means read and write are not possible. Read and write are not possible. Allow them to execute. Okay. And in the public access, you can just simply say we in this 0 we say not allow, and for 0 in the second sense we say allow. So we say okay, allow read, allow write, but don't allow execute. These are just scenarios. These are not actual. These are just samples. So this RWX, this indicate which users have permission to read, write, and execute. For example, this Windows XP, this has a ACL management list. For example, you can be an administrator, you can be a guest, you can be any of these type. These are group and usernames. Now, when you click on guest, you are allowing or denying something. That is, you are denying a full control, modification, read and execute, read and write. Okay. When you want to allow, you can check this. This is how the list is being made. This is a simple Unix directory listing. For example, we talk about this one, or we just allow, say, the first one, RWR. This is read, write, execute. So these are the formation which says whether it is allowed for a staff, what needs to be done. If a faculty is there, what needs to be done? For a student, what needs to be done, or what are the access which are being provided? There are other protection approaches also. The password can be associated with each file. This is one of the one of the intuitive form of protection, password. But the disadvantage is the number of password you need to remember can be very large. If you have only one password that is used for all files, then easily anybody can discover. So all the files that are accessible if it is known by someone. So only one password is associated with all the user files. So protection is all or nothing. There are two types of protection, all or nothing. But when we deal with multi-level directory structure, we need to provide a mechanism for this directory protection. In the directory operation that must be protected, they are different from the file operation. How? In the directory operation, we need to have control creation and deletion of files in a directory, and also we need to control whether a user can determine the existence of a file in a directory using, say, for example, DOS. We use dir command. So this is again some more part of very important topic, that is file system. Thank you so much. Take care of yourself.